This is Vijayalakshmi Bhadra and I am from BSc 6th and currently I am studying in Sri Siddheswar Government Postgrad College and PG Study Center, Nalgun. Today I am here to deliver my seminar on topic of flame emission spectroscopy (FES), limitations of FES, and determination of sodium and potassium in soil or water samples. Flame emission spectroscopy. In flame emission spectroscopy, measurement of the radiation emitted by the excited atoms is measured and it is correlated to concentration of the sample. FES is generally used for the determination of alkali and alkaline earth elements. This technique is useful for qualitative as well as quantitative analysis. Alkali and alkaline earth metals gives characteristic color to the flame. Limitations. Limited number of elements that can be analyzed. The sample requires to be introduced as solution into fine droplets. Many metallic salts, soil, plant and other compounds are insoluble in common solvents. Hence they can't be analyzed by this method. Since sample is volatilized, if a small product of sample is present, it is tough to analyze by this method as some of it gets wasted by vaporization. Further, during solubilization with solvents, other impurities might mix up with sample and may lead to errors in the spectra observed. Flame emission spectroscopy, while a valuable analytical technique, it has several limitations. It's not suitable for all elements, requires high concentration for analysis, and it is susceptible to special interferences. Solid samples must be dissolved and the results can be influenced by flame conditions. Limited element detection. FES is primarily effective for detecting alkali and alkaline earth metals due to their relatively simple emission spectra. It's not as well suited for elements that form complex molecules or have intricate emission patterns. Concentration requirements. FES typically requires relatively high concentration of the analyte to be detected. This can be limitation when analyzing samples with low element concentrations. Third one, sample preparation and liquid form. Solid samples must be dissolved into solution before they can be analyzed in FES. This introduces potential matrix effects and can limit the applicability of the technique to samples that are difficult to solubilize. Spectral interferences. The presence of other elements in the sample can interfere with the emission spectra of the analyte, leading to inaccurate results. Flame conditions and temperature can also affect the emission lines, requiring careful control and calibration. Flame interference. The temperature of the flame can influence the intensity and characteristics of the emission lines. Precise temperature control and the calibration are crucial for accurate results. Flame conditions can also affect the formation of molecular compounds which can interfere with the emission of atomic lines. Subjectivity and qualitative versus quantitative analysis. While APS can be used for quantitative analysis, the subjective nature of the observing flame colors in basic flame testers can be limitations. The use of spectrographs and detectors in FES provides more objective and quantitative results compared to simple flame tests. Flame emission spectroscopy is a technique is used to determine the concentration of sodium and potassium in soil and water samples. It involves nebulizing the sample into flame where the sodium and potassium atoms are excited and emit light at specific wavelengths. The intensity of this light is measured and correlated to the concentration of sodium and potassium. Sample preparation. Soil. Soil samples are typically prepared by extracting the sodium and potassium into solution, often using ammonium acetate. Water. Water samples can be analyzed directly, but sometimes pre-treatment like filtration may be needed to remove particulate matter. Second one, flame emission spectroscopy. Nebulization. The sample solution is nebulized or atomized into flame using an air or acetylene or air or propane flame. Excitation. The sodium and potassium atoms are excited in the flame, causing them to jump to higher energy levels. Emission. As the excited atoms return to their ground state, they emit a light at specific wavelengths, characteristic of Na 589 nanometer and potassium 466 nanometer. Measurements. The light emitted by the sodium and potassium is collected and passed through monochromator or filter to isolate the wavelengths of the interest. Third one, calibration and analysis. Calibration curve. A standard curve is created by measuring the emission intensities of known concentration of sodium and potassium solutions. Analysis. The emission intensities of the unknown soil or water samples are compared to the calibration curve to determine the sodium and potassium concentrations. Thank you all.